Okay, so we got a plane that lands on a runway at a velocity of 200 meters per second. So that would be my initial velocity. Okay, over a 15-second period, what did they just give me? Time. Okay, it slows at 6.5 meters per second squared. What did they give me there? Acceleration. Is it positive or negative? Negative. That's something to watch for. All right, acceleration is negative 6.5 meters per second squared. We're looking for the final velocity of the plane after that 6.5 seconds. So A equals VF minus VI over T. Okay, so that's going to be, we have to isolate VF. So what do I move first? T. All right, so I multiply both sides by T. What do I do with VI? Add it to the other side. Okay, so now I'm solving for VF. So VF will equal 200 plus 15 times negative 6.5. That's crucial. That would be the thing people would forget to do. Right? And so when we punch all of that in, okay, we got 200 times, or sorry, not times, plus 15 times negative 6.5. All right, so it'll be moving at 102.5 meters per second. Positive 102.5 meters per second. Okay, everybody all right with that one? Okay. This is a very typical question that you could get, and it doesn't seem like it gives you enough information. Okay. So we have a rock that falls from a cliff, okay, and reaches a speed of 42 meters per second. How long did it fall for? Okay. What am I supposed to do here? The question gave me two things. Actually gave me more than that, okay? It gave me, well, actually only gave me one thing, but it gives me, in a covert sort of way, two more things, okay? Which are an initial velocity of 0. Anytime something falls or is dropped or whatever, it starts from a velocity of 0. Unless it's thrown, fired, or projected somehow, okay, its initial velocity is 0. What else did they give me? They gave me the acceleration. I have to assume this object is falling where? On Earth, right? Where the acceleration due to gravity is 9.81 meters per second squared down, which would mean this is also which direction? Down, right? Because that's the direction things fall generally. Now, do I need to make down negative in this question? I don't, because nothing is ever up in this question, right? So I can just make down positive at the end of my question. At the end of the question, the downs will cancel because I'm looking for time, which is scalar anyway. Right, so always be on the lookout for that. Once in a while you get a question like this and it doesn't seem like it gives you very much information, but some of it is intuitive. Okay? I often put questions like that on unit exams, and some people get really messed up on them. And they're like, I don't know what to do. They'll actually write, not enough information. Well, yeah, there's only one number outright given to you there, but there are other pieces of information. Okay, so A equals VF minus VI over T, and we're looking for T. So what do? Multiply both sides by T and divide by A. All right, so T is going to equal 42 minus 0 over 9.81. So we got 4.3 seconds. Okay, are we all right with that? Questions? questions there? Does anyone need that one up there a little bit longer? All right, try that one. Looking for initial velocity here. Okay, so for this one, right, we have a race car that reaches a velocity of 80 meters per second, okay, after accelerating at 4.5. So we got VF, 80 meters per second. We have the acceleration, 4.5 meters per second squared. Okay, since we're not told otherwise, okay, those are positive. We're not told otherwise. For 12 seconds. Okay, what is its initial velocity? Okay, so we have A equals VF minus VI over T. So this is the most involved manipulation of this formula that you have. All right, so we're going to first multiply both sides by T. Then we're going to add VI. Okay, and then we're going to subtract T times A over to this side, which will leave us with VI equals VF minus the change in velocity. Right? And when we plug in our numbers here, that's going to be 80 minus 12 times 4.5. All right, so our initial velocity was 26 meters per second. If you got questions on this, guys, don't be afraid to ask, okay? If there's any issues with the algebra or understanding how I'm deciding which thing is which in the question or anything like that, okay, let me know. For the most part, for me, there's two ways I tell what given I'm being given in the question. First thing is I look at units, okay? Anything in meters per second is a V. Anything in meters per second squared is A. Anything in seconds is T. Okay, that's the first way. The second way is the context of the question, right? And this one here, because you could be given two things that were in meters per second, and this one says it reaches 80 meters per second. That means it didn't start there, okay? That's just a matter of it's almost like reading comp from English, okay? I have to read the question and comprehend that that means it didn't start at 80. That kind of stuff. All right, here's one where the direction changes. Okay, so that's a good one to practice because that's the kind that would give you on a test. Okay, it wouldn't be as easy as the last one. Right? So on this one here, you're looking for the acceleration, okay, but remember that the direction changes in the question. All right, so for number 4, we're looking for the acceleration. So A is our question mark, that runs out of gas while moving up a hill at 6.5 meters per second. So that's when it runs out of gas. Initial or final? Initial. So I'm going to say up the hill, positive. Okay, so positive 6.5 meters per second. Okay, it rolls for 8.52 seconds, so that's a time. Okay, and its final velocity is 3.78 meters per second down the hill. That's negative. All right, so I'm looking for A. The nice thing is I don't have to manipulate the equation. I just have to make sure I get the signs right, okay, and then I'll be okay here. So A equals VF minus VI over T. So that's going to be negative 3.78 minus 6.5, positive 6.5, okay, divided by the time, which was 8.52 seconds. Right, so that would be the challenge here, is that people would forget that the 3.78 needs to be negative, and then they would get completely the wrong acceleration here. So negative 3.78 minus 6.5. Now, this is something that I saw came up, and I think I talked to you guys about this on a few people's labs, which, by the way, I'm going to talk about next. Okay, in terms of how they're entering things in their calculator. Okay, if you enter this equation into your calculator like this, you will get a different and incorrect answer, because your calculator is programmed to do order of operations, not to do the top of an equation before the bottom. So you need to indicate to it that there's a top of the equation and a bottom of the equation, and as a result, one gets done before the other. Okay? If you type it in this way, you get this. All right? If you type it in the correct way, okay, which is negative, whoops, sorry, in brackets, negative 3.78, okay, minus 6.5 divided by 8.52. Okay, you get a much different answer, and you get the correct answer this way. Right? So please make sure that when you're doing your calculations, especially any ones that involve the top of an equation with a plus or minus, dividing by something on the bottom, you're going to need to make sure you use brackets. Top of the equation divided by the bottom. If you just type it in all in one line, your calculator assumes it's a skill testing question, like on so many contests. Okay. Have you ever noticed that? Okay. All those like free contests and whatever, they always have a skill testing question, and it's always a math order of operations question. Always. Okay. So make sure you punch it in, okay, the way it's supposed to be done, not all in a row. Okay? So if you put it all in a row, the calculator will do it the wrong way. Well, the right way mathematically, but the wrong way for you. Does that make sense? All right, I think you have one more. Okay, so now what I want you guys to do is just, rather than me keep interrupting you, just get some kind of uninterrupted practice here. So these questions here are in your digital workbook, okay, which is in Google Classroom. And I just want you to try a few of those. I have the answers already in there, so you can check them as you go. Okay, so it's under worksheet packages here, and it is the physics workbook. And we want to be on page page is this? 10. Okay, so it's on page 10 of this workbook. Don't worry about question number 1. The wording of it always gets people, so hey, don't worry about that. Start on number 2, okay, and let's see how we do here. All right, so starting on number 2, try a bunch of those, okay? And if any of those give us trouble, then just ask, and I'll do that front on the board. Okay? I don't foresee too much trouble, because you guys seem to have your math and algebra down pretty good, so that's good.